My name is Jeff Urich, and I'm the Mechanical Engineering Manager at McKinstry in Spokane. McKinstry is a mechanical contractor and engineering company, and together our mission is to build a thriving planet. Our mission is to make every building we touch more efficient, and my part of that is to make either buildings operate more efficiently with the energy that they use to heat, ventilate, and air condition them, or to at least use the energy they use more efficiently and wisely. I think the future of HVAC is pretty exciting. I mean, we've been living in buildings since we moved out of caves, but we continue to improve. I think the challenge of getting off fossil fuels is going to be a big one. There's going to be resistance in the market. There's going to be resistance in the mentality of the people around us that say this is change and I don't understand it. And it'll be our job as ambassadors to say, here's what I can tell you about what I see coming, and help educate the populace about what this change means and what it means to them. If you walk into your favorite coffee shop and you look up and see that ductwork across the ceiling, there's no formula that says exactly how that's supposed to go. There's some art to that. And especially when working with the non-engineering clientele, whether that's the shop owner or the architect that's got a vision of the commercial space, they're going to help you understand creativity, whether you like it or not. So coming in with an open mind and being willing to try new things and not expecting every single job to look the same is really important. And then embracing that opportunity to be creative is going to make you successful. A typical timeline would be to graduate high school, go to an ABET accredited 4-year institution with a mechanical engineering program, and that would be 2 years of general study, 2 years within the mechanical engineering school. Then, once you've earned that EIT, you need to get some on-the-job experience. That could be 4 or 5 years, depending on which state you live in. After you've gotten that experience, you fill out the application to sit for the professional engineering exam, and then you'll get to sit. You'll take the test. It's an 8-hour test. It takes all day. It's open book, but there's a lot to know, so you still have to know what you're doing. And then after you pass that, you'll get to be a licensed mechanical engineer in that state. And if you move to another state, you don't have to take the test again. You can seek a COMITEE application, which is like reciprocity for engineers, and you can get licensed in other states that have the same requirements as the state that you tested in. When you are a mechanical engineer designing buildings, at the end of the day, you get to see a building. So then you've built part of your city, a place you can drive by and show your friends and family and say, I did that. And I can tell you more about that than anybody else. For me, we've got a job up on Wellesley and Monroe that's a net zero building, which means it doesn't use any more electricity than the solar cells on the roof can create. So I'm not impacting the power plant. I'm not taking power off of the grid. I can give back more electricity than my building consumes, and the building still does its job. So why don't we build every single building like that?
My name is Derek Larson, and I'm a lead mechanical engineer at McKinstry. A typical day for a mechanical engineer is usually in the office. We are using our computer a lot of the time doing calculations, modeling of our building systems, coordinating with other individuals in the office, not just with our group, but with our construction side as well. But we also get to go on site to look at these systems that we've installed. And it's very rewarding to look at a system that we've designed and put on paper and to go out in the field and actually see that installed and operating. We use math and science every single day. Everything we do requires a number of calculations. There's a lot of focus on heat transfer and thermodynamics and fluid dynamics, understanding how pumps and fans are going to work, understanding pressure relationships. Almost everything we do requires some mathematical approach to it. One of the most rewarding things about what we do is having a happy client at the end of a project. Many of the projects we work on are in rural areas where our customers are schools and cities and counties and they don't have a lot of money. And as part of what we do, we help them get money to execute these projects through energy grants or other state grants. And we can provide them a new system that meets all of their needs. Maybe they didn't have air conditioning before, and now they have air conditioning. And it's very rewarding to walk in to a building after 6 months of operation and have the customer say, the system has been working great and we don't have any complaints.